So today we are working on 5.3 day 2, which is our double angle formulas. So our first problem, we are going to prove that tangent of theta equals 1 minus cosine of 2 theta all over sine of 2 theta. So for this one, I'm going to work on the left side of the equation because that one is the most complicated. And we're going to use the formulas that we went over yesterday. So if you don't have those memorized, which is okay, you can go and take a look at our notes from yesterday. We know the sine of 2 theta is 2 sine of A cosine A. And then we're going to have to choose one for our double angle formulas. And we are trying to get to tangent, which is sine over cosine. So we're going to choose the one that has sine, only sine in the answer, because that will help us simplify a little bit faster. So that's 1 minus 2 sine squared of theta, which is going to go on the top of our equation in our example for today. We will keep this 1 minus in the front because that is separate. And then we're going to be subtracting 1 minus sine squared of theta. Because that was our double angle theorem equation from yesterday. And then on the bottom, we're going to have 2 sine of theta cosine of theta. Then the next thing we're going to need to do is we're going to have to distribute this negative so that we can combine any like terms that we have in our numerator. So we're going to have 1 minus 1 plus sine squared of theta all over. Our denominator won't change yet, so that's going to stay the same. And then we can cancel out any like terms. The 1 minus 1 is 0, which leaves us with a sine squared theta in our numerator. Now, because we don't have any addition or subtraction signs in our numerator or denominator, we can cancel out any common factors. Oh, I am pretty sure I forgot a 2. This is supposed to be minus 2 sine squared. I apologize about that. So our cosine double angle theorem equation should be 1 minus 2 sine squared of theta. So now we can cancel out any like terms we have, and you'll notice there's a 2 in both the numerator and denominator, and we can cancel out 1 sine with each of them, which will leave us with sine theta over cosine theta. And that leads us to our final answer of tangent, which is what we were trying to get. So that is how you would simplify our example number 1. The last double angle formula that we're going to be going over is for tangent, and that one is equal to 2 tangent of A all over 1 minus tangent squared of A. This one also only has one formula, unlike the cosine, which has 3 different options, but again, it will be given to you on a formula sheet. So example 2, we're going to simplify 2 tangent of 15 all over 1 minus tangent squared of 15. And you'll notice that looks a lot like our formula on top. Instead of A, we have a 15 though, so we know that A is going to be equal to 15. It is okay to go back into the tangent of 2 theta. So for this one, we are going to do that, which will give us tangent of 2 times 15. Which will be tangent of 30. And because that is one of our special right triangle values, we can evaluate that. So the tangent of 30 is going to be equal to 1 over the square root of 3. And don't forget to rationalize your answers. I know the book doesn't always do that, but we are going to do that for full credit on our test. So we are going to make sure to do that right now, which gives us the square root of 3 over 3. So that is how you could simplify a problem that looks like this. All right, so our next example, this one's going to be a little bit longer, so make sure you pause it and get all of the steps written down. We are given that x equals 3 tangent of theta, and that will come in handy. We are going to write the expression below in terms of just x. So right now we have theta over 2 plus sine of 2 theta over 4. So the first thing we can do for this is we can simplify the two fractions that we have. We know that sine of 2 theta can be written out as 2 sine theta cosine theta all over 4. And then we can factor out this 2 from both our numerator and denominator of this fraction. Now you'll notice that we do have a common denominator, so we can just add these two fractions together. So we would get theta plus 2 sine theta cosine theta all over 2. We could also write this so we don't have a fraction in there, so we could just write this as 1/2 times theta times 2, or theta plus 2 sine theta cosine theta. Sorry about that. Now our goal for this problem is we're trying to write this expression in terms of just x. So we're going to have to do a little bit of solving using this information that they gave us. They told us that x is equal to 3 tangent of theta. So we're going to go ahead and solve this equation to get theta by itself. So we're going to start by dividing both sides by 3. And now we know that tan of theta equals x over 3. And to get theta by itself, we are going to get the inverse tangent of x over 3 equals theta. Now you'll look at what we have in our equation. We have sine and cosine. So what we are going to do is we're going to figure out what both of those equal. So we're going to use this information. We know that tangent of theta, the inverse tangent, goes from negative pi over 2 to positive pi over 2 from last chapter. So this is going to be in our first quadrant, which is x over 3. We're going to use Pythagorean theorem to find our missing side, which would give us the square root of 9 plus x squared. And we know this is theta. So now we can start filling in information that we know. So we're going to have 1/2 times our inverse tangent of x over 3, because we know that is what theta is equal to. And then we will still have plus 2. And we're going to be multiplying that by our sine of theta, which would be x over the square root of 9 plus x squared. And then we're going to multiply this by cosine of theta, which is 3 over the square root of 9 plus x squared. And then we can do some multiplication over here to make it a little bit simplified. We're going to leave this as the inverse tangent of x over 3 plus, in our numerator, we're going to have 2 times x times 3, which would give us 6x. And then our denominator, we have 1 times the square root of 9 plus x squared times the square root of 9 plus x squared, which will become just 9 plus x squared. for our problem. And that's about as simplified as you can get for this. I know it looks even more complicated than what we were given, but that is how we are going to leave our answer for this problem. And if you want a little bit more detailed review of this problem, it is in our text. And you'll notice here's the answer. This is on page 25 of the PDF, or if you have the actual book, it's on page 271. And they show us finding theta, using theta in our right triangle, and then simplifying our equation to get the answer that we have down here. All right. And if you have any more questions, please let me know and I will get those answered for you. The homework assignment is listed right here, and then that will be due when we come back to class next. I hope you have a great day.